Well, what are we doing today? Well, we've got this gadget here. Now, this was a collaborative project between myself and a local electronics store owner who since sold the business on. And this has come back to me. Now, my part in this was just programming up this little DigiSpark unit here to control everything else. But the whole unit's been landed on me to try and repair. So I have, of course, over here some of the original notes and the original DigiSpark unit and a few other bits and pieces. Now I programmed up a new one and it's been installed in here, but apparently it's still not behaving as it should. So let's explain what this is meant to do. This is from a funeral home and it's meant to control the curtains, and there's two switches that control open and closed, but those switches occur in multiple places and they can accidentally be both triggered at the same time, in which case things blow a fuse. So this box was created so that when the switches are pushed, it will only allow one to function at a time. If both are pushed, it'll just stop. So a little bit of logic happening in this DigiSpark, and there's a delay timer here so that nothing happens until the DigiSpark's booted. And then there's a couple of relays for forwards and backwards. In the big box underneath here, there's a 12-volt power supply and a 240-volt contactor to do the rest. So at the moment, we need to see if this does what it's meant to do. So let's plug it in. All right, so let's plug it in and see what happens. All right, so it looks like one relay is held closed at the moment. That's turned off. And this should disable for a little bit. Could be just the timer circuit. We're going to wait a few seconds and we should see that drop out. Okay, that didn't happen. Let's unplug and replug and see what happens. Got to let the capacitor run down in the power supply. So let's plug it again. It behaved fine for me before. Yeah. So I think that timer circuit's not doing what it should. Yeah, so that red light on that timer circuit should have come on, and it's not. I think that might be the problem. Anyway, let's hook up a switch and see if it behaves beyond that. I've got the lid off it now, and I'm going to plug it back in. See what happens. Now, this timer circuit worked the very first time I plugged it in, and that tells me that possibly it's a capacitor related issue, because now it doesn't work at all. That's pretty much the only reason I could imagine some inconsistent results. And I'm noticing input 1 fires up on boot up of the DigiSpark, which means that relay is not isolating those pins the way it should. Anyway, let's short across these pins, which is a switch. So we get input 2 is working. Input 1 is not. Okay. I was also lucky enough to have the designer's original notes here along with mine. So that could be a programming problem with the DigiSpark at the moment. So I'm going to swap out the old one. I think it might be fine. And then we'll try from there. Do this unpowered. Now, if you hear some funny noises in the background, there's somebody with a loudspeaker going out there, and I'm not sure what they're all about, but they're noisy. Alright, so let's take this unit here, and we will plug it in the way it was originally intended. I think he marked everything, and he put polarized sockets on these. Kind of handy. Alright, let's put that in there. Let's fire up now that we've swapped that out. See if we have any different behavior. Right. So far, not really. We should see a little flashing light when the DigiSpark's booted, which I'm not seeing. So we do have some different behavior. Interesting. So let's just power this down. We'll try one more time. So yep, there's no The onboard LED on the DigiSpark should flash when it's finished booting, according to my program, but it's not. So I think it's safe to conclude DigiSpark is probably knackered. So I think a few other things have gone with it. Let's get this other one in here, make sure we get these around the right way. I've just put pin headers on it. And this one goes in this way. Alright, let's just check that there is now a different behavior. And that will tell us it's probably the DigiSpark or my programming. Alright, definitely different programming. And we should see onboard LED should flash. That's good. That tells me it's booting. So I think it's probably had a power spike. And I think it might have buggered the DigiSpark, but it might have done this little chip here on the timing circuit as well. But crucially, that shouldn't affect the down switch. So I think there's a few components gone in here. Going to be an interesting one, this one. I'll probably need to check if both of these relays actually function. That's going to be an interesting one. I'll figure that out. And he's got a little logic level converter board here too, which he's done to pull things low, I think, if required on the board. I'll check for any pins. That'll be the postie. One moment. Right, so I need to find a way to test both relays, see if they're working. I might change the program on the DigiSpark temporarily to run a test program. That might work. Let's try that. Alright, so I've added some code in here, just an extra little section just in here that basically turns the relay pins low and high, alternating in 1/2 second intervals. So it should give me an idea if the relays are on, they should alternate one on, one off, one on, one off. Alright, so let's program that up. Alright, we've got our unit in. Let's just drop that down a little bit. Let's plug it all in and see if our relays work. Should go flash, flash, flash and start flipping these two lights backwards and forwards. Right, so both relays work. That's good. And this is going to go through a cycle like that. Alright, so now we're going to see if my inputs are working. See if I can test that somehow. Whilst I was inspecting things, I removed this little plug here, which is our 2 trigger pins. And I discovered there's a loose wire here, which happens to be the common one on the switch triggers. So I'm going to leave that off for the moment, and I'm going to see if I can use that to test the triggering. So let's fire everything up and see what happens here. I'll fire everything up. This should make it a little bit easier to touch this across to either of these. This is the common wire. Whoa. 50 Hertz interference on the common wire. Okay. I didn't put any buffering in the programming. That makes sense. Whenever you hear 50 Hertz in Australia, you freak out because that could cause problems. And that often means there's an electrical arc. So it's a very scary frequency to hear. Let's fire this up with those 2 pins back on the buffering circuit. Now let's try this. Let's try pin A once it's booted. Okay, that one works. Pin B does not. Okay. Interesting. So we had to pull those pins low, I think was the problem. I'm going to have to do some thinking. We'll be back. I'm going to have a crack at testing the trigger pins on this. Always got to be a message. Oh, that's my Argo tracker checking in. Anyway, we have a resistor here. It's got some yellow and purple on it, so I assume it's a pretty reasonably high value. It may or may not trigger this. Now we are pulling pins low, and we're pulling these pins pin 0 and 2 are being pulled low. So we're going to go off our ground pin in the middle here and see if we can pull you low with a resistor. I think this resistor is not low enough a value to do the job. Yeah. Alright, let's find another one. I should have something lower. Alright, what's this one? This is red. That's a something 0.2k. What are these guys? These are brown, red, black, gold. They would be 120 ohms at 10%, 5%. Sorry, gold is 5%. Let's try you. Trip across here. Will you trip a pin? If we pull you low, nope, and nope. Okay. Let's just disconnect these and see if we get relay hum again. Yeah, I thought we might. There's 50 hertz interference and they're floating high. So we do know at least that that side works. That side does not. Maybe that wire is not connected properly. Let me try the simple solution first. We're over the back here and we have our common wire which is white and our B relay wire which is red, and touching them together doesn't do anything. Okay, so if I touch common to A, that works. Okay, so I better put that back in the terminal screw and avoid that from touching anything while there's power. So let's unpower everything first. So I heard a little click and I hope that wasn't a component dying. It's always strange little clicks and noises. Sometimes are kind of not obvious, but they often are accompanied by magic smoke, which is not good because that's the witchcraftery that makes all electronics work, is magic smoke. Alright, so we're going to shove our common wire back in this terminal block too because it's getting a little bit loose and it needs to be back in here. If I can get it back in. I'm sorry if my hand's in the way, guys. I might have picked a bad camera angle. Let's bring you around here a bit. I'm fighting with a terminal block here at the moment and limited dexterity. I think that terminal block will go back in. Oh, I see that's how that happened in the first place. I think that terminal block was never actually in properly. So let's make that all the way in there and see if we actually get a firm fit this time. It might have been our main problem to start with, is that common wire was off. Okay, now that's in, we'll plug it in and we'll just test that we still have continuity on the terminal block, because that's the important part, particularly for the common. So let's touch our terminal here and alright. So that one works. That one does not. Alright, maybe we've got a broken wire somewhere. Let's do some more investigating. Alright, so I'm just testing this part of the circuit here. If we can move around here. Whoa, I have to adjust my camera. Hang on a minute. This is a bit of a tricky camera angle, but what I'm doing here is I'm testing my other relay bank and testing across 5 volts here and see if that will trigger, if I can get our pin in here. So that is relay 1 is triggering from this wiring loom. Let's go back to our orange wire here, which should trigger relay 2. Right, so relay 2 works. So everything should be working. The DigiSpark's sending instructions to the relays, all of that's happening. So really our only problem on this side of things is our red wire here getting message back to the DigiSpark through that circuit. Something's gone awry there, so that's I think where I need to look. Alright, so the next step I'm going to do, I'm going to take this little wire here. This is the trigger from the button circuit, and because I know one side of this works and the other doesn't, I'm going to try and flip the connections around. I'm going to mirror them. So I'm going to use some of these DuPont connectors that I've got floating around here. I'm going to hook a couple of them on here and swap them around. It will invert the way the relays will operate, but that will tell me if it's a circuit problem or something else. So I'm going to join on a whole bunch of these DuPont connectors. So I end up with a male to female setup. And here's the other one, and we're going to swap them around. So what have we got here? That should go on that way, which means this black wire that turns into a white one should now go to the red, which you're seeing off camera here. We'll swing around a bit. That should go into the red. And the only other option is that goes into yellow. All right, let's see how that goes. That's a temporary little jump. Let's fire this up again and see what happens. So let's, all right, so no 50 hertz buzz, that's nice. So wait for it all fire up. We've got our flash, flash, flash. All right, let's go common and test this one. Nope. Aha, I think we found our problem. Okay, so now the B relay works, but A relay doesn't. So if I do the fancy thing here, this is going to buzz like buggery for a minute. Plug you back in, swap them back in the correct position here, and A relay should in principle work again. Okay, A relay works, B doesn't. So the problem is going to be in this little Vero board that's down here, so, or prototype board rather. Let's move our camera around and have a look, because you probably can't see it from that angle. So these are the two pins I've just jumped. Now this is the connection for the relays, and this is a board here just to pull all the pins low until they're shorted, then pull them high. There are two sides to that. You can see here there are 4 resistors and 2 capacitors here, one for each unit. So I'd say one of those capacitors has probably failed. So I'm going to have to rip that board out and have a look. And that's something I'm going to do a little bit later on, because I've got a bunch of other stuff to do right at the moment. But I have contacted the guy that originally built this, and I'm just going to get his advice as well. But I might have to recreate that board. Anyway, we're making some headway. This component is still very much damaged. Something's not right with that. So I'll need to get another one of those. I'm going to get onto the electronics shop that this came through and see if they can get me another one of those. Anyway, let's move on. Alright, so that board's one of the short circuits. Kit's very easy to find. I've had the electronic shop order one of these in for me, and when it arrives, then we'll build that and put it in. And in the meantime, I need to rebuild this little prototype board, or at least find out what's wrong with it. There can't be too much wrong with it. Look, 2 ceramic capacitors and 5 resistors. There's not a lot to go wrong there. I reckon it could be maybe one of these connections has just got loose. It's wriggled around and come off the pad on the bottom. But that's hot glued down, so I'm not the only one that uses hot glue, so don't hang me. I'll peel that up at some point and we'll have a look. But I've got a couple other things to do today, so we'll be back at this fairly soon. Alright, so it's been about a week since we visited this project, and I made a couple of changes that I didn't bother documenting at the time. For one, I have replaced the DigiSpark here with an Arduino Nano, or Arduino Tech Nano. It's a an Arduino Nano compatible one from JCar. One of the reasons I did this is several pins on this, they are active during boot, and they're used for the USB communications and whatnot, which causes some relay clatter in this. The Nano has enough pins spare that I can find a couple that aren't active during boot. And I'm pretty sure with this little add-on board here, or the interface board, I can connect all this in the right pin configuration to match that. So now I've tested all of this, and the one thing I'm up to now, let's move our camera up. Where I'm up to now is this little board here. I'm pretty sure there's something wrong with one side of that. Only one side works, and that is to pull it high so that when you push the button it drops low and triggers this. So I'm going to rip that board off and try. And this delay board, I'm pretty sure we can render redundant by using the nano. So, but I'll figure that out in a minute. For a start, I need to work that board out. So let's get that ripped out. Okay, well I've got this board out and I'm just testing the relays. So we'll test this side and one relay works. This side, one relay doesn't. However, something I'm not going to repeat for the camera, I flipped the input pins on the Arduino and of course the other pin then responds. So that means this board is fine. So my problem now is something between this board and the Arduino, which could be just wiring. So we're getting closer, and I think it might be just one of the inputs that's not working on the Arduino, and it could be just programming. Alright, so my problem is this second pin from the end here, which is pin 10, and I think it's got a different purpose to what I'm using it for. So what I'm going to do is I'm going to shuffle all these down so that the original connector that was actually on here, that we can see up here, the original connector here that was used, I'm going to shuffle all the pins down the side here so that can sit in nicely, and hopefully reassigning the pins will help. But at least I know which pin I've got to fix now. So well on the way. Alright, so I got irritated with all the complications. I'm just going to start from scratch and simplify everything. There's two big contactors in this grey box at the bottom. I'm just going to focus on the low voltage side of things here. So we're going to get all this worked out again. So let's, and I think these are wired directly off the relay input, so I can leave these still in there. So let's continue on with the redesign. Alright, so I'm having a bit of a crack here at replacing things. I don't need 4 relays in here, but I have a 4 relay card that is opto-isolated and has some really nice convenient connections to make it really easy to do with DuPont connectors. And this can all go in here. I can feed 12 volts straight into that. I can run my 5 volts off the inbuilt regulator to supply the relays. Everything will work very well. We'll have 2 redundant relays for whatever else we want to use maybe in the future. Even if we don't, it's still easy to find. So we'll do a bit more working with this, but this is a lot more simple with really only 2 components to do the job now. It makes programming easier and I don't have to reassign pins. So, alright, let's see how we go with this. Alright, so I might be back to square one here. When I turn this on, one of the problems I have is the relays come on during boot. That's a problem because if both relays come on, both contactors are going to come on and we're going to blow a fuse. That's what this whole project was about in the beginning. The only thought I have is maybe if I pick up off this built-in LED, have it stay on for a few seconds at boot, we might be able to have a third relay isolate the contact while it boots up. I'm not sure. We'll have a think about it. Alright, I think I've programmed a solution up here. I've got my program up in the screen here. When I've had it, I'm having it make a delay of 100 milliseconds each loop, because when it gets 50 Hertz interference it was buzzing and carrying on. Down here I've made it wait a quarter of a second before it resets that first relay, so that I'm not having all 3 of these relays on all at the same time. So let's have a quick look here. So I'm going to use this relay here to isolate the input to these 2 relays so that any pin activity during boot is going to be ignored. And that is connected to this onboard LED here. So let's reset this. Isolates, then flicks these 2 and then shuts off. Let's try again. Isolates, flicks, turns off. Alrighty, now we can get on with making it trigger. Alright, so I just had a little slip of the finger and I bridged 5 volt and ground here. I've blown up the internal regulator on it. I do have another one of these boards luckily, so I'm going to rip this out and put the other board in. The programming on this is still luckily okay. If I provide it 5 volt from the USB port, it's fine. That's not going to work for this project though. I'm still having some trouble dealing with pulling pins high and pulling them low and mucking around, but I'm going to have to put this aside for now and come back to it again later. Right, so it's been a couple of days again since I last messed with this, and where I blew up the regulator. Now I think if I'm lucky, in here I have another one of these nano add-on boards. Pretty sure what I've done is blown up this little 5-volt regulator in here. So we're going to rip all this out and start again. Now, some of you might ask why I use hot glue with everything, and part of that is because it comes up very easy. It makes correcting one's mistakes quite repairable. I think I should would be the active word. Got a bunch of cables around my lap here I have to untangle. So let's just change our camera angle a bit here, and we'll pry this out of the board. Now I should really probably use a chip puller for this, but here's where I make my next mistake of the day. I'm going to try and lift this up a bit. I think I better find my chip puller. Alright, so over the side here there's a drawer full of tools. I have a chip puller here which may or may not be suitable for this task. We'll find out. I'll rip this nano up off the board here. There we go. Comes out nicely. Let's have a look here. Well, I don't see any obvious damage to that regulator, but I don't have time to really care about that. Now I've got to make sure I get this in the right way round. I believe that's the correct side. I'll check my photos before I power it up first. But that's in again. Now I have to come over to my box of bits again, and also swing my camera angle up. And I've got to put at least back in again. Yay. I don't think I'm going to glue it down. I'm going to stick it down with blue tack for the time being until I get everything working. I was a little overconfident in my abilities before. So, yeah. Alright, let's get this wired up again. Alright, I've had a bit of a muck around with the camera to see if I can get it in a better position. And clearly it's in the way of my hands. So let's put this in position. We'll worry about the USB lead in a minute. Now I need a blob of blue tack. This was multicolored blue tack till my apprentice got to it, and she's mixed it all into the one funny poop color. Alright, let's see if I can move my camera up slightly. Alright, moment of truth, let's supply 12 volts. El Zilcho. Don't like that. Let's make sure I do have 12.7 volts on the side here. This is connecting. No voltage. Huh. Let me check some stuff. Right, so it would appear my spare board has also got problems. I've checked everything and it looks like something's wrong with this board. That might be why I have it. If I'm really lucky, I've got another one somewhere. Let's have a look. Alright, so I don't have any more of those spare boards, and in lieu of actually going and buying something, we're going to take a whole different approach. We're going to rip all of this out, and we're going to chuck an Uno clone in here, and that might actually do what I needed to do. And at least the chip, the Atmel chip here is replaceable. And this unit in its entirety is about the same cost as this little combination here as well. So, yeah, let's stick an Uno in here, and then it's much more of a known quantity, a little easier to program, and I think I've got some more options, and the pin layout's a little easier to figure out too. So we'll do that. I know my Nano still works, but I had plans of using the Nano in a more discreet package, so we might do that. All right, let's open our Uno clone. This is a Arduino Tech clone. Fortunately, the people that have commissioned me to repair this are actually own the local JCar store, so parts are not hard to come by. I think this is going to work better, except for all the funny little piggybacks I'm going to have to do for all the connections, but we'll work that out. That's all right. We'll get it all breadboarded first and then see what we can do. Alrighty. Right, let's see if we can get away with programming this. I've got it up on the screen here. selecting comma 10, and let's go sketch and upload. We'll let it compile. Watching a little orange blinking LED here. I've changed all the pins to 6, 7, 8, 9. They're avoiding most of the crazy stuff. LED pin is still 13. Everything looks to be right. When I did the code, I used variables in place of the pin numbers. So at the top of my code, I can just change the pin numbers when I swap between boards. The value in doing code properly, even if you think you're never going to see the unit again. What have I got myself into with this? Oh, that transmit receive lights. Looks like we're programmed. Oakley dokley. Right, let's unplug and replug and see if this thing flashes the onboard LED. We should see a little flash, flash, flash somewhere if it works as designed. Or perhaps not. Well, I know which pin I'm using, so pin 13 should probably still be okay. Alright, yeah, let's see if this works. We'll get it all wired up. I have to adjust my camera angle slightly here. See what we can do. Come back down a bit. Alright, so where are we at? So I've set up pins 6, 7, 8, and 9 to be used. 6 and 7 are going to be inputs for the buttons, which connect down here through this little thing. However, I've run out of my male-to-male leads, so at the moment I'm just testing the relays, which are going to be outputs on pins 8 and 9. Pin 13 is what I assigned as the LED pin, but it's not quite doing its thing. In either case, that's set up as an output to run a third relay to isolate things at the startup. 5 volt and ground are coming off here. Now, hopefully this little regulator in here should do the job. Let's see what happens. Okay. So it's done its little click and it should do a startup. I forget these things run much quicker, so let's try again. Okay. So that is behaving as expected, except it's set both of those to high. I need to pull them to low. So anyway, we've got a little bit more programming to do, but that looks promising. All right. Let's hope I don't blow this one up. At least it's a little bit harder to accidentally bridge pins like this. When I'm done with this, I'll be setting up a little shield as well. And it sounds like I'm going to have to change my delays as well. But anyway, progress. We're back to where we were when we first got the thing, or even slightly ahead. I may need to duck up to the store and buy some more of these male-to-male plugs, but we'll work that out. Anyway, I'm going to take a breather and think about this because I've been making stupid mistakes, and also with change of medication for MS, my eyesight fluctuates every morning, so this sort of stuff's getting really tedious to do. So, all right, let's give it a break, and I'll be back shortly. Some more deliveries have arrived. Some bits and pieces, all up here. So, what have we got in this? We have some 5.6K resistors, also known as 5K6s. Some 9.1Ks, close enough to 10. Going to use them for pull downs. Sounds like there's another delivery. It's the perimeter beam going off. Now we've got an Arduino Uno replace or compatible one, and we've got some pin headers, some jumper leads. All right, 100 pieces of them in fact, but these have combination male, female, all sorts of stuff. These are ones I don't have, and I could very much use them for something I'm working on at the moment. Alrighty, let's see what else shows up. Back from the JCar shop, and we have some bits and pieces. I got a backup Uno clone, just in case. Got a bunch of resistors for pull up and pull down. Now notification's gone off, and my apprentice has come and found me. I got some jumper leads, which are male to female. So let's get fitting them in. Alright, so let's peel off a few of these jumper leads, as they call them, or header leads, or I'm losing track of my terminology. Anyway, we have a little multinational flag, I guess, or whatever. There's various different ways you could represent that, I guess. So we want several pins here. We're going to need 5, I think, for that. So yeah, let's peel off these all separately. Peel these two up. So we have 6, 7, 8, 9 pins here. 6, 7, oh, that was 6, 8, so 7. I've got it under blue tack, it's moving. 6, 7, 8, and 9, and pin 13 up here. All right, there's those ones. Oakley dokley. So we'll pull those off. Now, where's my program? Now, I can't remember what my pin out was. Anyway, I do know that pin 13 goes right here, which is our red one. And I think I've set 8 and 9 as relays off memory. We'll find out pretty quick, I'm sure. No, wait, the last 2 relays, not the first 2. So let's pick them up. And I haven't even wired the relays yet. Well, now I'm losing some dexterity, so I need my dexterity helpers. Here we go. Pick this guy up and drop you down on the adjacent pin. Oh, these can be pricks. We need to get them right. Alright, in we go. Sorry about the profanity there, guys, but I'm not monetized, so I don't care all that much. So those 2 off the side here, they're going to be for my buttons. Alright, now we need to look at 5 volt and ground, and they're marked, luckily, so I can rip them off. Right, use a brown for a ground, because it's close to black. Although in German automotive stuff like Volkswagens, brown is positive. So you are a ground. Okay, and we need one more. Where is the collection here? Let's take, let's not take black for positive, let's take a purple. A little bit distinct and less confusing. I have color choices now. Now you go into the 5 volts. So we have volts in, ground, 5 volts. So that's blank pin. Okay, right, there we go. So that bit is hooked up. These things need to hook out from there. Okay. All right. Cool banana-ramas. Right, now we can hook 12 volts up and just make sure that side of it works first. Let's whack out 12 volts in here. Let's turn 12 volts on. All right. Okay, and we do, if I can see the red lights in here. Yes, we've got 3 red lights. Okay. So, now to do a bit of tweaking to the program, and then we might rewire the relays as well, now that I've hot glued them in place. Alright, we're making progress. We might almost have this done by the end of the day. Alright. Right, so I'm basically back to where I started after this tremendous loop. So I've got this unit, will start up, it'll do its boot, it'll put all 3 relays on, turn these 2 off, and then turn that off with a delay. That means it isolates these, so we're not going to blow a fuse. Now, I've got it set up so if I pull this out, not necessarily both of these, but if I've got the internal pull-up resistors enabled on the input, so if I isolate this pull-down resistor, which is about 10k, it operates that relay. Problem is, if I pull this one, it doesn't trigger, which is the problem I had right to start with. I don't know why this is happening, and it's the same programming I used before that was working, but everything comes down to looking like it might be programming. I don't want to have to rewrite this program from scratch, but I think I'm going to have to. Alright, let's try what else we can do. Alright, real quick, I've got this set up here. I've got 3 relays. This relay is meant to stay on until we trigger something to avoid short circuits. I've got these 2 pins pulled to ground by a 9k resistor. This one will trigger a relay, this one will not, and I don't know why, and I'm going nuts, and I've tried several other systems and boards and whatnot. I got no idea what's wrong. Alright, just to add to this, pins 5 and 6 on here are inputs, 7 and 8 are outputs to relays, and 12 is an output. I had used 13 for the onboard relay with the DigiSpark. Alright, so I've been mucking around with the code, and I asked a mate. I cleaned it all up, put some notations in, and I spotted, or they spotted, this line here. I wasn't reading, this line didn't exist. I wasn't reading the state of my button pin 2, so I couldn't actually do anything on it. Beyond that, I couldn't act on it. So now that I fixed that line, that relay works, and if some idiot pushes both buttons, they stay off, which is exactly good, and it means we're not going to have short circuits. And it means when we reset this, all 3 relays come on, the other 2 turn off, and then the isolation relay turns off. That means it's working. I can wire this up and button it up and get it off my desk. Alright. Right, so I've got everything stuck back down in the box, and I'm running on its internal supply now, and things are working as they should, and if some idiot pulls both buttons, nothing happens. Right. Okay, so I've got it open and close. Alright, that's good, with a slight delay, which is fine. So now I just need to hook up the output connections again, and we should, or the input for the switches, but we'll be nearly done. Right, I think I'm there. Now if I can get this wire out of the focus, let's move along here. This contact down here is for the original switch contact, so should be able to see if I can do this through the lens, which I can't, I'm a bit blind. Right, so that's one working. Over here should be 2. That's 1 and 2, and idiot mode, if you push both of them together, doesn't work. It's good, or it does work. It's preventing idiots from pushing both buttons at once. So, I think we're about right. Now, in this little bit of heat shrink down here, there is a 10K resistor hiding in the heat shrink. That is the common contact for the switches. That should be pretty right. So I think what I'm going to do now is just try and neaten everything up, make it look a little bit better, because it's got a transparent window. We can't have a crazy rat's nest going on in here. Alright, so I've neatened this up a tiny bit, and I've got a thread stuck. I have to twist that a bit to get the lid off, and I have no grip from all the hand sanitizer that I've been using lately. Anyway, this could be neater, and this cable routing could probably be less messy too. Couldn't find my baby zip ties, so I've used a bit of heat shrink here, but it should keep together. And I've used the fabled hot glue to hold a couple of these little DuPont connectors in here. If this does become a problem, I'll make a board to sit over the top of both of these and connect everything. But for the meantime, this will work, and I'm sick of seeing this on my desk. So we'll get this off the desk. And I've finished cleaning up the code. I've done a full printout. I've updated the notes and everything for that. So yeah, we should be right. Alright, well, I've neatened everything up. I couldn't find my baby zip ties, so I've used a bit of heat shrink here. And a little bit of hot glue in a few places to hold these DuPont connectors in. I know people will be screaming about that, but at this point, I'm not worried. This lid's going to go back on the top. Everything works as designed. I've done a full printout of the code. I've cleaned it up, corrected my notations. Everything's right. So I hope we don't blow a fuse. I'm hoping the timing on these relays is close enough that that won't happen. I haven't worked out how to change that yet, but I'm going to leave this sit overnight while I talk to some programmers about how maybe to do that. But the programming connector is easily accessible, so I can get back into that again if I need to. And all this is off-the-shelf parts, so next time it should be easier to fix. Anyway, I'm going to leave this here. I'm sick of looking at this thing. I need it off my desk. So it's been about 3 weeks of between everything else I've had to do, so I think I'm almost done. See you all in the next video. I hope this was interesting.